Okay, so this time what I'm going to do is I'm going to add together two numbers, two mixed numbers, so 3 and 3/10, and I'm going to add that with 2 and 2/5. And the problem I have is that I can't add 3/10 and 2/5 together because I don't know what 2/5 is in tenths and I don't know what 3/10 is in fifths. So what I'm going to do is I'm going to find a common denominator. And so I look at my denominator, that's the number most down, and in this case it's 10, and in my other case it's 5. And a nice easy way to find a common denominator is to list the multiples. So I'm going to write 10 over here, because that's one denominator, and I'm going to write 5 over here, which is my other denominator. And if I find a number that both of them go into, so like a family essentially, then I'll be able to add my fractions together because I'm going to change them into the same family. And so for example, if I look at 10 and I look at 5, well, I know that 5 will go into 10, don't I? Because 10 is a multiple of 5. So if I change both fractions into tenths, then I'm going to be able to add them together much easier. So I have 3 and 3/10 plus 2 and 2/5, but I want to change my fifths into tenths. So if I find out how many 5s are in 10, I can then multiply my numerator by that total, and I'll be able to change them both into tenths. So there are 2 5s in 10. So I'm going to multiply now my numerator up here by 2, which gives me 4, and now I can add them together really easily. So first and foremost, I'm going to add my fractions, so 3/10 and 4/10. That's going to give me 7/10 altogether. And then I'm going to add my whole numbers, which is 3 and 2, and 3 plus 2 is 5. And so my answer is 5 and 7/10. And we'll look at another example of this, and I'm going to clear all of this out, and this time we might take a harder example. So let's say we're given a sum, we have 3 and 3/4, and I need to add that to 2 and 3/5. So again, the problem is that my denominators, the quarters and the fifths, are different, and I need to find a common denominator. And I can do that by finding a common number that both 4 and 5 go into. So I'm going to write 4 over here and 5 over here. What I'm going to do is I'm going to run through my multiples. So I'm going to start with my 4, and 4, then comes 8, 12, 16 and 20. And because I kind of know my tables pretty well, I know that 5 is also going to go into 20. So let's just prove that. So 5, 10, 15 and 20. So I know that both quarters and fifths, they can both be changed into 20ths, and I can add them together. So I take my 3/4 and I'm going to turn that into 20ths. And in order to do that, I look at my denominator, which is 4, and I see how many 4s are in 20. Well, I've already proved that over here. There are 1, 2, 3, 4, 5. So if I multiply my numerator by 5, I'm going to get 15 over 20. And then what I need to do is I need to do the same with the fifths. And I have 3/5, and I'm going to change that into 20ths also. So again, I look at the denominator, see how many 5s are in 20, and again I've proved that over here. There are 1, 2, 3 and 4. So if I multiply my numerator by 4, 4 3s, so that's 3, 6, 9 and 12, I have 12/20ths. And now my sum is really easy, because now what I'm going to do is I'm going to add 3 and 15/20ths plus 2 and 12 twentieths. And because they're both 20ths, I can add my fractions together. So if I start off by adding together my fractions, 15 plus 12 is 27. So I'm going to get 27 over 20. And then add my whole numbers. 3 and 2 is 5. I have 5 and 27 over 20. But I don't really like that because I've got a top-heavy fraction. So what I need to do is I need to change that into a fraction and a whole number. So 27 over 20 is the same as 1 and 7 twentieths. I'm going to put 7 twentieths over here. And I'm going to add the extra 1 to my 5. So 5 plus 1 is 6. And my answer then is 6 and 7 twentieths.